it's 13 seconds live. Sorry for watching me drink that long. Okay, all I want you to be able to do in this lesson, it's a bit of a summary, so I think it's a pretty good lesson for a Friday. I just want you to be able to look at a bunch of graphs and tell me what they are. So, not really sure how we have a viewer. I'm pretty sure this is private, but whatever. I just want you to be able to look at a graph and tell me which one of these are they. Or be able to look at an equation and tell yourself what should that kind of look like. And that's really it. So if you've got an x, straight line. If you've got an x squared, parabola. If you've got an x cubed, cubic. If you've got an x to the power of an even number, parabola. X to the power of an odd number, cubic. Over the x, hyperbola. A to the power of x, exponential. And you've got an x and a y squared, then you're looking at a circle. Now, that's it. I just want to stress, I've left this point up there. If you're trying to find the equation of a graph and you're like looking at two and you think they're both it and you're not really sure, just remember that any point on a graph has to satisfy the equation. So this point needs to satisfy whatever your graph is. So let's suppose it was y equals, it's an exponential and it's flipped that way. Maybe it's 2 to the power of minus x or something like that. Then I should be able to put minus 2 in there and I should be able to put 25 in there. If I do that, so if I do that right now, that's 2 to the power of 4, that doesn't equal 25, so this isn't my equation. So these are the kind of things you can do. You can use your point to verify your equations. All I want you to be able to do for this lesson is be able to look at them and literally match it. So there'll be 6 equations. There's 6 equations in this example. I just want to be able to be like, okay, this one's that, this one's that, this one's that. But I'm going to go a little bit of a step further. I'm actually going to derive them. So I'm going to get them from scratch. But I don't expect you to be able to go that far. Well, I would, but like, you know what I mean? You don't have to. But it's a good skill to be able to do that. So if you wanted to do this exercise without looking at the equations, then that would be a bit of a challenge in itself. Now, for the first one, a, I know that it's an exponential. So I know that a, you just got to think about the certain properties of it. So an exponential looks like this, a to the power of x. So I've left that in the top corner up there as a reference. Now, it's going backwards. So your normal exponential, I always think about relating things to the normal graphs, like your normal parabola looks like this, your normal cubic looks like this. Your normal exponential sometimes is a little bit confusing. Your normal exponential, I think of it as a tick, so it looks like a tick. If you go like that, kind of looks like a tick. Now, it's reversed this way. Now, it's sometimes confusing whether, like, it's reversed. I know that it has to be a minus somewhere. Is the minus here or here? Well, when you put a minus out the front, it flips upside down, just like a parabola. If you put a minus x squared, it goes like this. So if I had a negative like that, instead of it being a tick, it would actually go like this. So the fact that it's backwards the other way tells me that there's meant to be a minus up there. So there's a minus here. Now, the next thing you can think about is my output needs to be 25. Now, if I'm inputting something in here, how am I going to get 25 out of it? Well, the only way I can think of it is if it's something squared, hayouts. So if I had squared there and I had 5 there, that's going to give me 25. But I've got a minus here, so maybe this needs to be like a minus minus. So these are the things I would think about. And what does this a value have to be? So at this point, this is where I go, all right, let's substitute our points in. And I know that it hasn't been moved up and down because it cuts at 1. So I'm not concerned about there being a plus c on the end because it hasn't been moved up and down. So at the point, what is it, minus 2, 25, I'm anticipating a is going to be a 5. That's what I'm thinking. So that means 25 equals a to the power of minus 2, which is a to the power of 2 equals 25. I could use logs here if I wanted, but I'm pretty certain that a in this case is just going to be 5. A is equal to 5. If I really wanted to use logs, I'd take the log base a of both sides. It'd just be weird. There's no point. I know that's going to be a 5. So that means, therefore, my equation is y equals 5 minus x. That would be how I get the first one. B. I think these are pretty self-explanatory. Like, this is a cubic, this is a parabola, this is a hyperbola, this is a circle, this is a straight line. It's pretty easy if you look up here which ones they're going to be. But I think deriving it is a fun skill in itself. Now, I know this thing's a cubic. I know it's backwards, so it's upside down. So I know that it's y equals minus x cubed. It's been moved, so the normal cubic looks like this. That little, it's called a point of inflection, but you don't need to know that. The point where it does its little swivel thing has been moved up 8. So that means I need to go up 8. Okay, and do I have any points? Yes, I do. I've got this point here, so I'm just concerned whether there's whether there's a number out the front here. I want to know what that is. If it's 1, then cool, but let's figure out what it is. So this point, let's substitute my point. I actually have 2 points. I've got the point 20 or the point 0.08. Let's go with 20. So 20. 0 equals minus a times 2 cubed plus 8. That's minus, now 2 cubed is 8, so that's minus 8a plus 8. That means 8a equals 8. That means a equals 1. Okay, so therefore I've got y equals minus x cubed minus 1x cubed plus 8. Cool, that's the second one. C. Move this over. Let's see. Okay, so parabola, it hasn't been moved left or right by observation because the axis of symmetry is in the middle. So it hasn't been moved left or right. So that means it's going to be y equals x squared. So it would be x minus something squared if it had been moved, but it hasn't. It has been moved down though, so minus, it hasn't told me how far down it's been moved. So minus something. C. Okay, now I've got the point 2, oh no, I don't know how skinny it is either. Okay, this is where I run into a problem because I don't have enough information. Let me go down to here. Yeah, damn it, doesn't have information in this one. I can't actually derive this. My problem is I don't know how skinny it is, so there should be like an A value here. And in order to find 2 values, I need to know 2 points on the graph, but I only know 1 point on the graph, so this one's actually impossible. So, I'm sorry. Not enough. Actually, yeah, not enough info. But the answer tells me that it's 2x squared minus 3. And I can verify that. Like 2 and 5, if I put a 5 there and a 2 here, that's 2 to the power of 2, which is, what's 2 squared? 4 times 2 is 8, minus 3 is 5. Yep, okay, that makes sense. It would be much better if they gave us this point, which is minus 3. If they gave us that, then we'd have a fighting chance, but we don't have enough information. Okay, D, that's a hyperbola. Now, a hyperbola looks like y equals something on x. Now, it's backwards, so the normal one is both positive, positive, negative, negative. So like positive x, positive y, negative x, negative y. But this is backwards, it's in the wrong quadrant, so that means there must be a minus at the front. It hasn't been moved up or down because my asymptote is here. It hasn't been moved left or right because my asymptote is here. So I'm happy with that. If it was moved up and down, I need that. If it was moved left or right, I need that. So it hasn't been moved. I just need to figure out what this k value is. Now I've got a point, minus 2, 2. So at minus 2, 2, I've got 2 equals minus k on minus 2. That's 2 equals k on 2. That means 4 equals k, and therefore y equals minus 4 on x. And that's my solution to that. Look, this exercise is really easy if you're given all the equations, but I think it's fun to try and derive them. Okay, this one's a circle. X squared plus y squared equals r squared. Hasn't been moved left, right, up, or down. It's got a center at the origin, so that's why I've written this. If it had been moved this way, I'd need an x minus something. If it had been moved that way, I'd need an x minus, a y minus something. Hasn't been moved at all. This is the trick question in these. It's really easy to just be like, okay, that's x squared plus y squared equals 3. It's not. It's x squared plus y squared equals 3 squared, because the radius is 3, which is the same as x squared plus y squared equals 9. Last one, straight line. We should be able to do these from the start of this year or last year. There's a million different ways of doing it. I could use rise over run. I could use the 2 points. I could, there's a few things I could do. But because I'm given the graph, I'm just going to start with what I know. It's y equals mx plus c. Now I know what y-intercept is. It's -4. It's a y-intercept, so I'm just going to write y equals mx minus 4. And what I was doing before was substituting points. And I tried to show people that this year, but that was confusing people. So then I said just find the gradient instead. So now I'm going to switch back to using the point. Like if I wanted to use a gradient, I just go, okay, well this is 1, 2, 3, 4. That's 1, 2. So it's rise over run. So it's going to be -4, so that, which is -2. But if I substitute a point, I don't know. Actually, it's not -2, it's +2 because in the positive direction. Idiot. Substitute a point. What point do I know? Well, actually, I know 2 of them. I've already used this one, so let's use this one now. That's 2, 0. 2, 0. 0 equals m times 2 minus 4. 0 equals 2m minus 4. 4 equals 2m. M equals 2. Therefore, y equals 2x plus, no, minus 4. Okay, so or I could do rise over run, which is 4, what did I say, 4 over 2, which is 2, therefore m equals 2. That's my other option. It just so happens with a straight line that we have a couple of options because we've been looking at straight lines for ages. But yeah, all I want you to be able to do is identify graphs, and generally you're going to be given the equations of the graphs, you have to think about how to match them, and in this case they're all really, really different. But if they were kind of similar, like if I was given this and this, then you might do some thinking, which is, I think, what the exercise does. Yeah, okay, so see, there's like straight lines and these exponentials are often things people get confused with, particularly because they're almost identical and they almost have the same points on them. And then here, sketch each of those graphs. So it's just a bit of a recap. The power plus was particularly interesting, especially these questions. I think it would be kind of interesting to see what people come up with. But yeah, that's it for this one. That's actually graphs. We've completed graphs. How lovely.